So I am going to talk about not so fast transients with UGMRT, and so this work is done by various people, and it is in a not in that much matured state, but some part of it you have already. So if I cover the first transients with GMRT, this first radio burst part we have heard a lot during this conference, and so one part of that is the follow-up of repeating FRBs, and other part is discovering the new FRBs. Other than that, mostly in this talk I will be talking about the follow-up of study of rotating radio transients, which also can be classified as follow-up of known rotating radio transients and discovery of the new ones. Other than that, there is of course strong pulses from pulsar, which could also be thought of as a progenitor of the first radio burst, and the connection between all these things we have already known about. So these are the faces you all know who are present in the conference and are giving their talks. They have done a lot of work on follow-up of repeating FRBs with UGMRT. So I'm not going to detail of that. But now coming back to discovery of new FRBs with GMRT. So we are conducting the GMRT High Resolution Southern Sky Survey. With that, we have covered this part of the sky, southern sky, with a reasonably high sensitivity. And we have discovered quite a few pulsars, but we have not detected any first radio burst over here. There are some candidates, but so where we saw band limited structures, but manual investigation on those are required. So as of now, there are no FRBs discovered in this survey or with GMRT, I would say. Now I'm coming to what are the rotating radio transients or RRATs. So these are these kind of sources. So from pulsars, we see extremely regular pulses at their spin period. If the pulsar is something called nulling pulsar, then you will see some pulses in here are missed. There are something known as extremely nulling pulsar, where you will see the fraction of nulling is much more. Then there are these RRATs where you sporadically detect these pulses. So, and these RRATs are very difficult to time because of this sporadic nature. And you will see that in literature, as of now, around 125 RRATs are known, out of which only 30% are known to be timed, and very less of them have long-term timing solution. Okay, so so since we don't have long-term timing solution for most of these, we don't know if they have glitched, if the timing solution that was described in the discovery paper is still holding or not. Okay, so now as Yogesh also had shown in the plot, he had the pulsars and RRATs are unlikely to be the counterpart of FRBs because of their energetics and also the magnetic field. But we can, in this talk, I will try to see the similarities that in the properties of these rotating radio transients and RRATs that we have. So with UGMRT, we have followed 3 well-timed rotating radio transients with simultaneously band 3, which is 300 to 500 megahertz, and band 4, which is 550 to 750 megahertz. And in this table, for one of the RRAT, I have listed the rates at which we detected the pulses in pulses per hour. So where we see that the detection rate is varying a lot, and between 2 frequencies and with one epoch to another epoch, which is kind of similar as is seen for repeating FRBs, that they have certain activity periods and detection rate varies, and again function of frequency. So what we have seen is this temporal changes in detection rate is kind of a similarity between RRATs and FRBs, and this higher detection rate we see in band 4. So that we don't know if that is also the case in FRBs, whether this frequency dependence is that constraint. But for these 3 well-studied RRATs, we could see that this band 4, UGMRT band 4, is a space where we see higher detection rate. But I have to also say that this detection rate is also function of telescope sensitivity, which will also be the case for fast radio bursts. So like if you use a telescope like FAST, you will see more number of bursts, but even then it will be dependent on the frequency. So the question is whether we can think of RRATs as something like galactic counterpart of repeating FRBs, agreeing on that this energy budget problem, though that this FRBs, if they are like, if they have, if we consider that their distance is like galactic distance, even then we cannot match the energy, the luminosity that we see from FRBs and RRATs. So maybe these are, so we don't know, but whether RRATs could be the likely counterpart, or maybe there are some more energetic RRATs which are yet to be discovered and rare. So, and another thing is repeating FRBs, we don't have, so for RRATs in general, these 30% which are timed, we could see the spin periods and the timing model we could get, which is not available for these FRBs, which is a negative point while tallying these 2 sources. But again, 70% of RRATs are, we are not able to time them. And also placing these 70% or even this 30% to extragalactic distances, the timing will be even more difficult. Okay, so now coming back to, these are some collection of single pulses that we have detected from this RRAT, which is one of the first discovered RRAT with the UGMRT. We see different kind of structures in this thing, and some places people may see that the nature of the emission is kind of similar to what you can see the frequency structure at places are similar to FRBs. So here what I plotted is say this band 3, simultaneous band 3 and band 4 pulses. So this band 3 pulse has the band 4 counterpart is this. So we see that in band 3 generally, I should not say generally, always there is there is a turnover kind of thing. So at higher part of the band 3, these RRATs are not detected, though it is stronger at band 4. So this is indicative of some kind of low frequency turnover for RRATs, which is again till now it was not known, mainly because of like not studying with wide frequency wideband telescopes, and also the limitation in number of known RRAT, having timing model, etc. So band limited structure is seen for RRATs, which is similarity with FRB, and like there can be follow-up studies of RRATs and seeing similarity with FRBs and also with the known pulsars. Now I am going to looking at the single pulse spectra, how those compare between RRATs, FRBs, and what is known from the literature, in the literature for pulsars. So this is some published data. So Kramer et al. Have studied single pulse spectra for a bunch of normal pulsars, and they have reported the spectral index for single pulse is varying in this range. So though we all know that this like the spectral index, mean spectral index for the average pulses ranges from in this range, though there is some spread between like if depending on which pulsar you are considering, this range may or may not hold. And also like Rahul have recently published that for a collection of millisecond pulsars, the mean spectral index is varying with time. So temporally, depending on which epoch you are observing, you are seeing different spectral indexes. But the single pulses are known to be varying even more. and Kramer-et-al. Long back in 2003, they have shown this kind of pattern. So though this is like seen long back, we could not see a lot of literature on this. So on the like variance of the single pulses for the normal pulsars. And also interestingly, for the pulsars that emit giant pulses, there we see the like Crab pulsar, the spectral index range is even more. Single pulse spectral index delta alpha is like the power law index range is around 20 to 25, and also it is, we can see that though there are some part of the this thing is spectral index ranges in the negative spectral index, we also have the positive part which is not present over here. Now coming back to again on the IRATs that we were studying, if we plot the distribution, it is more like the giant pulse emitting Crab pulsar, though there are again statistically we are not comparing with many of the giant pulse emitting pulsars for which the data is not available right now. So what we are saying is IRAT single pulses are falling in between the single pulse spectral index range for normal pulsar and the Crab giant pulses. Okay. And the other thing that people generally do while comparing the pulse energetics is they do this flux energy, cumulative flux energy distribution, and it is known that the giant pulse emitting pulsars generally follow the power law trend, whereas the normal pulsars are following the log normal trend, and we found that the IRATs are generally following the log normal trend, though at the high energy tail maybe the power law is better fit. Okay. Now, so I have already told that we have detected some IRAT pulses simultaneously at band 3 and band 4 for 3 of the IRATs. So now if I take one of the IRAT and for one of the epoch to keep the other things comparatively similar. So for one of the epoch, if we stack all the simultaneous band 3 and band 4 single pulses for this IRATs, we clearly see this turnover kind of thing that I was telling, the evidence for that. Okay, so we have here made the stack only using 8 single pulses, but one can again like observe for longer duration and verify this. So there is a turnover kind of thing that is seen. So that lower frequency, we are seeing that this IRAT is showing some kind of turnover. We have fitted. So this is for another IRAT. We see the same thing where we saw after fitting the spectra turnover around 440 megahertz, and for this IRAT again I'm showing the fit where it is again around this value. Though for normal pulsar generally the turnover is seen around 200 megahertz. So for IRATs we see the spectral turnover at relatively higher frequencies around 400 megahertz. So one can check, though in FRBs the band limited signature is much more pronounced, but one can see whether such similarity with this behavior can be found. And I should also give a caution that for the IRAT, where we are seeing there are some simultaneous pulses between band 3 and band 4. For some band 4 pulses, we do not see any band 3 counterpart, which could be due to the turnover happening even at higher frequency than 440 megahertz, so that at band 3, full band 3, which is starting from 300 to 500 megahertz, we are not seeing the pulses. Okay. Now coming, so I have talked about following up of known IRATs. Now I am coming to the discovery of IRATs. So with GHRSS survey, single pulse search pipeline, we have discovered 3 IRATs, and this is the discovery plot of one of the IRAT, though this is a like extremely clean plot. Generally, we have a like this kind of plots where we see discoveries is very much messed up with RFI. And this system is being followed up for timing by Ella from West Virginia. Now, again, the next thing is strong pulses that we can detect from pulsars, whether those can be progenitors for thought of as progenitor for say fast radio burst emission. So regarding that, with GMRT, Saptarshi has worked on this around say 235 giant pulses he has detected from GMRT observation, and he has a poster, so you can, which is displayed here, you can look at it. And also, in addition to this spatial pulsar, there are other pulsars for which Spotlight is continuously taking data, and Ankita today will be talking to us about the strong pulses that she has detected with the Spotlight and how that can probe the possible synergy between neutron stars or pulsars being some kind of connection with the FRBs. So I would now summarize my talk. So I have talked about, so this part is already talked about in this meeting. So I have talked about the rotating radio transients and the possible similarities on the behaviors on, say, temporal detection rate of rotating transients, the similarity in possible spectra and turnover in the spectra, and more comparison of, say, spectra, energy distribution, and more regular observation even of rotating radio transients, and like finding more suitable. So like maybe these 70% of rotating radio transients that are not well timed, maybe one of those are similar, like kind of counterpart of galactic counterpart of FRBs, which can give us some clue on, like, maybe not the full population, maybe some part of it. So yeah, I will leave it you at that, and maybe Ankita can tell us more on the strong pulses. Thank you.